In the last lecture, we have discussed the data transfer and arithmetic. Now in this lecture, we will discuss the remaining instruction groups. So logical. Now these are all instructions I forwarded in the notes. It is available. So whenever you try to write the program, you have to refer these notes. Now coming to the logical instructions, and or XR, rotate, compare, and complement. Now here you can see the first instruction format. We will see the, now this is the compare R. Compare R is nothing but, it will compare the accumulator content with the register. Now this is the format. Now here you can see the example. Compare B. Compare B means what? A will be compared with the B. How the comparison is taking place? By subtraction. Now the B value will be subtracted from the A, and result is not stored in the A. In the coming to the sub instruction, what sub instruction is doing? If I take sub B means what? B is subtracted from the A and result is stored in the A. And flags are also affected. Now coming to the compare is how it is comparing means it is subtracting the B value from the A value. Now, whatever the register you have taken, that value is subtracted from the A, but result is not stored in the A. So only flags will be affected. By checking the flags, we can say that which value is greater or which value is lesser, or if both are equal or not. Now, when its subtraction is taking place, if A value is greater, then no carry will not generate, and result also not zero. If this value is higher, now for example, if this is 9 and this is 7, so we will get the 2 value. So for 2, what? These flags will not affect. These flags are reset. Now if the value of A is smaller, 9, 7, and B value is larger, then that time, so borrow flag will set, means what? Carry flag will set. If the carry flag is set means what? It is giving the information that A is greater than the B. If both the values are equal, then the result will be, both are 7, then the result will be 0, 0, 0. Thereby, Z flag will set. If the 0 flag is setting means what? Both the values are equal. So depending upon our requirement, we have to, by using these flags, we need to write the program. This is the compare instruction. Now, while if you are sorting the numbers, or if you are searching the number, that time it will be, these instructions will, this instruction will be useful. Now here, compare R means what? Any register you can use. That register will be compared with the accumulator value. And what is the difference between subtraction and comparison? Means subtraction, the result will be stored in the accumulator. Now in this case, result is not stored. Accumulator content is not going to change. Okay, now compare M means what? In the memory, HL pair is pointing to one location. In this location, whatever the data is there, that data is compared with the accumulator. Now remember that all arithmetic and logical operations we have to perform only with the accumulator. That's why here you no need to specify the accumulator. The default, if you are saying B means default with the accumulator. M means what? Default with the accumulator. So this is about the compare instruction. And this is most important for writing the programs. Now next, compare immediate means what? Instead of giving the data, you can instead of writing the location here, register here, you can specify the data directly. So now this data you are comparing with the accumulator data. Whatever the data is there in the accumulator, that you are comparing with this data. And the same accumulator, if suppose 90 is there, and if you are comparing with the 89, now if when it is comparing, so there is no carry will generate. So that's why what? It is A is greater than the B. If carry is generated means what? A value is lesser than the B. If zero flag is set means what? Result is all zero. Zero flag is set means what? Both the values are equal. Now, because the data is specified, we have to write I, immediate. Now, next one is what? And anding with, anded with R. Now R is nothing but what? Register. Any register you can specify over here, including A also you can specify here. Anding B register with the A register. Now for example, if A is containing 10 and B is containing 9, then how to do the and? For 10, how to write the binary value? For 0, you have to write 4 zeros, and 1 you have to write 0, 0, 0, 1. And how to write 9? 9 means 0, 9. First upper value is upper nibble is 0 and lower nibble is 1 0 0 1. Now for this, do the AND operation. If both 0 and 1 means what? 0 0 0 0. If both are 1, then only we will get the 1. Otherwise all are 0. Now this is the result. Result will be stored again in accumulator. Now this is about the AND operation. Similarly, M means what? In the memory location, whatever the data is there, that data is affected by the that data is ANDed by the accumulator. Similarly, AND immediate, whatever the data we specified here, this data will be ANDed with the accumulator content. Now, this is what XOR, exclusive or XOR. So instead, just now I have said A value and B value. So instead of taking the AND operation, you have to use the XOR operation. What is XOR? If both are zero, if both are zeros, both the values are same, then you will get the 0. If unequal values are there, then that time you will get the 1. Exclusive OR gate truth table, you have to see now 0 0 0 0 and 0 0 0 1. This is the A value. If B value is like this. Now if both are 1 1, then it is 0 0 0 0. If opposite values are there, 0 excludes R1 with 1 means what? 1 you will get 0 0 1. This is the answer which is stored in the accumulator. Now M means what? Again with the memory location. Similarly, ORing, doing the logical OR. If any one of the value is high, then we will get the logic high. Similarly with the immediate data. Now rotate left. Rotate left means what? Now if this is the accumulator content, accumulator is holding the 8-bit data D0 to D7 and this is the carry. Now rotate left means to your left data will be moved after giving this instruction. Now D0 will come to the D1, D1 will come to the D2 and so on. So D7 bit will go to the carry flag and again the D7 will be moved into the D0. Now if accumulator value is now if I take 89. So 8, I have to write 100, 9 means 001. If carry flag at the beginning, if I'm considering it as a 0, then after using this RLC, then what happens? So this bit will be moved here, this bit will be moved here like that. Now, so if I write the bits 100, 01, 000, this one again will come to the first. So this one will come here and also this one will go to the carry. So this one is coming to the carry and also coming here. So what is the value here now? This is 3 and this is 1. The carry is 1. Earlier, what the data we have applied? We have applied the 89 with the carry 0. Carry flag is 0. Now in the after the rotation, rotate left, what the value we got? Carry is 1 and the value is 30. So the data is moved towards to the left side. Now similarly, rotate right. Now the same thing you have to do the right position. You have to rotate in the right. So now that is how. Now this is the carry and D7. D0 means what? Here. So this D0 bit will come to the D7 bit and also come to the carry and D7 bit will move like this. So data will be moved in the right side. So this is about the rotate right. Now coming to the RAL means what? Rotate left with carry. Rotate accumulator left with carry. Means what? Earlier what we have taken without carry. Means what? The MSB bit is moved into this and also MSB bit is moved into the D0. Now in this case what happens? Now this is the if the this is a D0 and this is a D7 means what? D7 will be moved into the carry and carry will be moved into the D0. Instead of moving the D0 to the D7 to the D0, now carry will be moved to the D0. Now for example, same example if I take 89 and carry is 0. Carry is 0. Now 89 if I move then what happens? This is 0 0 0 1 0 0 1. If I move then 0 0 0 this carry will come here. So 0 carry will come here and these values will move like this 0 0 0 and carry will be 1. So now this is the data. What is the result of this? No, this is the first value, and here it is the second value. Now what is the value of this? This is 2 and this is 1 and carry is 1. Now after the with the carry, you are getting the carry 1 and the value is 12. So 89 become 12. Now this is about the with carry. Similarly, rotate right with carry. The same rotate we have to take and we have to consider the carry. Now these are the important uh, rotate operations. Now next one is a complement. So whatever the data is there in the accumulator, so that will be complemented. Ones will be become 0, zeros will be become ones. Now if this is the value, then 1 becomes 0, zeros become 1. So now this is 0, 1, 1, 0. Now what is the value of this? This is nothing but 7 and this is nothing but what? 6, 76. This is the complement. Complement with the carry. Now here we need to consider the carry. Set carry. If the carry is 0, now we are setting the carry value to the 1. Now coming to the branch instruction, this is a jump instruction. This is the unconditional. Now if we use this instruction, whatever the address we are specifying, so to that address it will jump. Program will jump to that address. Now this is the conditional. Here X means what? X means you can use the any one of the flag. Now here carry flag. JC means what? If the carry is set, then the JC need to use carry 0, then the no jump no carry, jump positive, jump minus. So this will use the sign flag. Jump 0, jump not 0. It will use the 0 flag. Jump parity even, jump parity odd. It will use the parity flag. Depending upon the flags, so we can use the jump instructions. So these are most important. We are going to use these instructions frequently. Now coming to the call. Call instruction is for the subroutine. Already I have explained at the time of classification. Now call instruction based on the condition, the flags. Now this is the written instruction. Branching. Now coming to the branching instructions. RST. RST is a reset. Here we are using reset. Now sometimes now in the program, I am saying that a halt. Instead of halt, we can also use it as a RST3. So there are total 8 reset programs are there. These are the software interrupt instructions. Total 8 RST0 to RST7. So total 8 software interrupt instructions are there. For halting the program, sometimes we will use the RST3 also. Now coming to the control, no operation means what? Whenever we need to provide some delay, that time we will provide the NOP. With that one, microprocessor will not do anything. So delay will be provided by using this. Halt means what? To end the program, to stop executing. DI means to disable the interrupt flag, enable the interrupt flag. RIM, this is the RIM instruction. By using this instruction, you can mask the interrupts and also you can send the data in serial. Now, similarly, RIM instruction, that is the RIM, and this is the SIM instruction. You can mask the interrupt bits and also you can send this data serially out. So these are about the logical branch and control instructions.